Hello everyone, welcome to our tech briefing. Today I'm doing the tech briefing from Berlin office with Michael Henretty. He will be presenting the famous project Common Voice, and he will be telling the story about Common Voice and how to contribute in this project. So please, if you have any question, just write it in the Etherpad, or you can write it in our tech speaker channel, Reps channel, and I will be delivering the questions to him.
Thank you so much. First of all, thank you, Manel. Thank you, Javi. Thank you, tech speakers, for showing up. It's an honor to be here. It's an honor to be talking to you today. Unfortunately, I have a little disclaimer. We had our engineer who was going to present, and he has some slides. Unfortunately, he can't make it today because we are very close to a multi-language launch, which I'll talk a little bit about later. So I have his slides. I'm going to go over them, but I don't have as much detail as he does. And so if there are any questions that I can't answer, I'll be happy to follow up with you afterwards. But as Manel said, this is an introduction to the project of Common Voice. There will be two parts to this. The first is the story of Common Voice itself, kind of like the why we exist. And then I'm going to go over some of the architectural stuff, the code type stuff for you, code monkeys who want to talk about how to contribute to the code side of the project. Okay, without further ado, let's talk about the story of Common Voice. But first, a little bit about me. So my name is Michael Henretty. I'm a strategist for the Open Innovation team. I was hired by Mozilla about 5 years ago as a front-end engineer working on Firefox OS, which I'll actually talk a little bit about as well. But these days, I'm working on Common Voice. And so you probably have heard about what Common Voice is. And you also probably know what this device is. This is an Amazon Alexa, a smart speaker you bring into your house. But right now, the internet or the web, the World Wide Web, and these smart devices, these speech recognition services, they don't play together so well. And that's what I want to talk about. But first, let's take a step back. So you might recognize this. A few years ago, Mozilla was working on a mobile phone operating system based on the web. It was called Firefox OS. As part of this effort, we were building a voice assistant very similar to Apple's Siri. So we wanted our users to be able to give voice commands to do common tasks like search the web, text their friends, send emails, stuff like this. However, it was really hard for us to build a voice assistant of the same quality that people expected from Siri or OK Google. And there's a reason why. You see, computers, like our phones and our speakers and our desktops and our laptops, they learn to understand human speech very similarly to how humans learn to understand human speech. They have to listen to and process a lot of talking before it can understand the meaning behind these words, right? Before it can understand what the words are. And actually, in the case of computers, or in the case of voice, computers learn slower than humans do. So you need a lot of this example, what's called voice data, to teach a computer to understand humans. To give you a sense of scale for how much data we need, how much voice we need 10,000 hours, and what that equates to is about 10 times all the TED Talks ever given in the world. I'm sorry, not 10 times, 100 times all the TED Talks ever given in the world. So if you ever listen to a TED Talk and collected every single one of them that's on the internet, you need to do that 100 times before you could even have a single language and a single accent speech recognition technology, right? So this is a big amount of data, and it's really hard to find this data. And so we encountered this problem as we were building this voice assistant for Firefox OS, and the voice assistant was called Bonnie. And we were first looking for English, and we were looking all over, and it turns out that there are a few data sets out there, but most of them are really small or really expensive, or both. And if we're looking for data sets other than English, in accents other than North American male, well then you're almost out of luck entirely. And meanwhile, Firefox OS itself, we had a vision, as you might know, to bring the next billion online, right? We wanted to put the web into hands of people who hadn't experienced the web before. We wanted to put it right in their hands. And what this meant was really inexpensive phones, so think around 20 euros, which we actually did hit. And then localized content in emerging markets like India, Africa, Bangladesh, right? But unfortunately, there just are no voice data sets of the size and collection that we needed in these markets. They don't exist at all. It's hard enough in English, right? So that's why Mozilla started the Common Voice project. It actually wasn't always called Common Voice, it was called Voice Bank back when we originally started, but last July we rebranded as Common Voice. Common Voice is Mozilla's initiative to crowdsource a large public data set of human voices to be used in speech technology so that every accent, every language, every gender can have equal access to this technology. It's pretty simple how the project works. We built a website where you can go and record your voice by reading sentences. You can also listen to the sentences that other people have recorded and verify if what they said is accurate. This is an important part of the overall quality of the data set because we need it to be super accurate to make sure that our speech recognition engine is super accurate, right? And then at the end of the day, we make all of this data available on our download page, licensed with CC0, so that's pure public domain. You can use it for anything you want, whenever you want, whatever you want to do with it. And right now, well, so far, we've collected about 800 to 900 hours, I think it's like 850 hours of English data. And most of this comes from US, or not most of it, I should say, about 20% actually comes from US, but that's the biggest contributor. But then the next biggest is India, followed by Germany, then Thailand, and then all the way down to 100 different countries have donated to this data set in English, right? So the English data set is pretty diverse in terms of accents. But English is just the beginning. As I mentioned earlier, we wanted to empower whole new communities to have speech technology. And so a lot of our efforts recently, and indeed right now, are around collecting voice data in multiple languages. And something that you are actually hearing first, because we haven't officially announced this yet, we are going to be collecting voice data in German, French, and Welsh. These are the three new launch languages that are going to be happening very soon, in fact, in days, maybe a single day. So that's our next effort. But you might ask yourself, well, if Mozilla is no longer building this amazing web-based smartphone, then why are you still collecting this data? Like you don't need a voice assistant anymore. Well, that's a good question, and I'd like to talk about that now. First and foremost, Mozilla is still building the world's most advanced open source speech recognition engine. It's called Deep Speech. It's on GitHub. It has about like 6,500 stars. There are a ton of people who are contributing to this and following along with this. Last November, this project passed a milestone where it was able to understand English read human speech better than humans can. So a human can understand about 96% of the words that we hear, right? We have sometimes we hear things wrong. It's about 4% of the, or about 4% of the time. Well, our engine is actually better than that. It has a smaller error rate than humans. Last November, and we are continually improving this. However, as I said, that this is only in English so far, and it's mostly with North American accents. So we need to continually build our data set to make this a more inclusive engine, but we've only just begun. But in addition to the Deep Speech project, which is a really important consumer of our data, there are problems in the voice ecosystem that we want to address. And at the forefront of this voice ecosystem are the rise of these smart voice assistants and smart speakers that we put in our house, right? You've probably seen some of these products. If you peel back the covers of this market, it's actually not much of a market at all because this industry is dominated by a handful of only very small players and nobody else. And there's a reason why there's only a very small amount of companies that are very rich companies that are taking part. And that's because building really accurate speech recognition is extremely hard. We already talked about the data piece, right? That's the part that Common Voice is trying to address. But even if you're able to do the data piece, you still need a team of machine learning scientists, which are very hard to hire and very expensive. You need highly specialized computing power. That's also very expensive, and you need to run that continually, so you need to have some sort of access to infrastructure. And then also, something that's talked about much less is that voice recognition is a patent minefield. There's just so many different ways that companies have made proprietary just processes. For instance, you can't even do a client-server architecture for speech recognition without paying this company called Nuance, which is up here. You might not have heard of them, but they're a very big player in this space. You have to pay them money just to even make a server for a speech service. So this is a really significant economic hurdle. And in addition to all this, if you're somehow able to do all the things I just mentioned, then you still have to build a product or service that can compete with these existing players in the market, right? And so this has created a winner-take-all scenario that is stifling innovation, and it's preventing all of us from taking part. And I don't just mean people, consumers from around the world, I mean voice service providers. I'm thinking hobbyists, startups, universities, researchers, anybody besides one of these players. It's really hard for them to get involved. And so we want to disrupt this and empower whole new people to be able to build voice services by making it cheap and easy. So that's another reason for Common Voice to exist, as well as deep speech. And if we talk more generally about voice and why we care so much about voice, it's that voice technology has an incredible potential to do good in the world. It's not just about convenience. It's not just about being able to do something on the go or do something without your hands, but think about people who are sight impaired. Voice technology, like screen readers, have always been a big deal in their lives, and if voice technology could empower people who are sight impaired to interact with more pieces of technology, this would be a really beneficial technology for them. Not just sight impaired, but also maybe physically impaired. So if people can't use a keyboard or a mouse or a screen. But then there's also large parts of the world that are illiterate and who have no access to the internet, no access to this information. But if we had a voice assistant, we could bridge the gap and perhaps provide services that can help people take part in this technological revolution, right? The dream of bringing the next billion people to the internet, or bringing the internet to the next billion people, is still alive with voice. And then, of course, children and the elderly. This is another big story that we think voice can help unlock potential for. So that's it. That's what Mozilla is doing in the voice space. We want to disrupt this kind of closed ecosystem and empower whole new generations of people to be able to take part in this technology and also take part in the internet. As I said, Common Voice is just the data piece itself, which we think is really interesting. But then we also have Project Deep Speech, which is intrinsically linked to Project Common Voice. And these two pieces together, we hope will make speech technology cheap and easy for any type of person who wanted to build a voice service, or consumers who wanted their voice to be heard and understood. So that's it. As I said, this is me again. You can get in touch with me on Twitter or on, here's my email address. I think maybe before we move into the architecture piece of this talk, which is, again, not my slides, but I would love to pause here and see if there are any questions. Are we able to do that? Or should I go through the other part first?
I do have like 2 questions of you. Maybe we can do that first. Yeah, you said that we need to pay the Nuance company for setting up a speech server. So someone from the tech speakers is asking why we need, if you can share more details about that, why we need to pay them.
Yeah, so in America anyway, so this is not a worldwide patent, but there's a patent in America that this company Nuance holds for the architecture of having a client device record your voice, send the recording to a server. The server does the speech to text translation, and then sends that translation back to the device, right? This is a pretty common paradigm for doing like any sort of web-based interaction, right? Well, Nuance, 20 years ago or so, saw this as a very powerful paradigm for voice, and they patented that process, believe it or not, and that patent went through. So in America, all of the big companies you see, like Siri, Alexa, OK Google, they use this sort of architecture because no voice recognition is done offline right now. It's all in the cloud. And so they have to pay royalties to Nuance just to even put up this service. And so if you are a university trying to do a free and open source version of a voice recognition service, well, guess what? It's not free because you're going to have to pay Nuance just to even have that in America. So this is something that, so the way we are addressing this is we hope that deep speech itself, this is the voice recognition software we're building, can be done in an offline local manner. So we are building deep speech so that it can be installed upon a Raspberry Pi or an Android phone, and will allow you to not have to set up a server, but can do everything on the device. And this is not just great for avoiding that patent, this is also much faster because there's no over-the-wire communication, it's all done right there, as well as it's more private because the data doesn't go anywhere into the cloud, it's all local on your device. So you kind of get control over this data. So there's kind of many facets to why our deep speech is taking this kind of offline approach, and the patent is just one of those angles.
Perfect. Thank you. I do have another question, but it's a little bit technical, I think.
Okay.
We have Kayan is saying if it's moved to other, if the common voice is moved to other languages, how the speech engine tackles the dialects for each language.
Yes, that's a very good question. Dialects, accents, different ways of speaking as well as different ways of writing. There are many kind of variables when it comes to collecting voice data. And as you are mentioning or as you're calling out, it's much more useful for a speech recognition engine to be aware of these details for a number of reasons. But one of the biggest reasons is that you could specialize your speech recognition engine to, for instance, recognize Scottish English, or maybe Hochdeutsch, which is like the northern spoken of German. The way that Common Voice is addressing this is through identity on our website, and this is something that we're just starting to explore. So if you go to the Common Voice website now, you'll see that we have a profile. And in that profile, we ask people to identify what kind of accent they speak with the current language. English being the only launch language right now, but as I said, that's changing very soon. This accent list that we have right now, it's not very comprehensive. And so what we have been doing is working with members of the standards body called ISO, and we're using some of their recommendations on how we can classify different regional dialects and different accents to allow our users to self-report kind of the way that they speak. This is not an easy thing. This is not a science. In fact, the ISO body, whom we're working with, has recently kind of gone back to the drawing board, started over with their standards work among accents. So really, this is going to be an ongoing challenge for us to kind of track correctly. Thankfully, though, the Common Voice Project has a group of speech and linguistic experts who are advising us. We call them the Speech Advisory Group, and these consist of people in academia for both big and small languages, like under-resourced languages like Welsh, for instance, Bangor University in Wales, languages like Hebrew, Arabic, French. It's really all over the world, both academic and commercial. And what we try to do is address this from a use case. We try to say, okay, if you were a consumer of this data, what sorts of metadata points would be useful for you? And we're starting to collect a way to collect that metadata. And so there's a lot of work to be done here, and we have not done it perfectly yet, and it's going to be an ongoing challenge. But I'm pretty confident over the next year, as we sort of learn about this data set collection, that we can get to a really nice place. One of the ideas we're kicking around right now, to get pretty specific with you, is we think that if we have users identify what is their native language, where did they grow up from ages 2 to age 5, and then where did they go to school, we can kind of encapsulate a lot of the different pieces of what makes up an accent. Because it's not just region, actually. It's also, for lack of a better word, it's also how posh you speak. So someone from London, two people from London, depending on what school they went to, could speak very differently. And so there are ways to find this out. It's just not a highly standardized process yet. So this is something, sorry for the long answer, but it is definitely something that we spend a lot of time on, and it's something that we are constantly trying to address, and we will be improving as we move along.
Perfect, thank you. It's actually a very detailed answer, and I think it's connected to my next questions, which is about contribution. So besides contributing to giving your voice, like for example, I'm an Arabic person and I can give my voice in English because I have different accent as American English. So I think that we need that for Common Voice, and also maybe what do you recommend? You recommend contributor to give their native language more than like English in different accents? So this is the first question. The second question, besides giving away, like providing your voice, is there any technical way to contribute in Common Voice project? Like I know maybe it's related to your next presentation, but just if you have any call out of contribution, and people can know how to contribute, and even like for tech speakers, if they want to make like a public speaking, like in a conference or anything about that.
Great. Yes, there are definitely multiple ways to contribute. The first question, I'll answer the first question first. Which is, if you have an accent or if you have a native language, like what's more valuable to us, right? Should you be speaking in your native, or should you be speaking in English, which might not be your native, or whatever language is not your native that you also speak? And by the way, congratulations for speaking multiple languages. This is great. We actually want both, and it's really important that we get both, because the current voice recognition technology is really kind of biased towards native speakers of, as I said, North American male speakers, right? So Siri works really great for me. It might not work for most people in the world, right? A vast majority, like 80% of the world, it's not so good for. And that's one of the things we're trying to address, is that we want accents to be recognized. And so, yes, definitely, if you don't speak a language natively, but you know how to speak a language, we want your voice. And in fact, you will be contributing to making voice technology better for people who speak with your accent by contributing your voice. So please do. But also, if you speak natively one of these languages, so for instance, we're launching in German soon, and if you speak German, we would love that as well, because in a lot of languages besides English, they don't even have German data, or they don't even have native data sets. And there's some big holes in this data set space. For instance, Hindi is a hugely spoken language. I guess it's not, there are many people who don't speak it natively, but also speak it. We could not find any Hindi data set at all. So if we could create a Hindi data set, we can empower a whole new types of communication through the speech technology. And so, yes, we want native, we want not native, pretty much any language that you can read out loud, that you have that ability, please do it. So that's to answer that question. In terms of how to contribute, there are multiple ways, and as you noticed, or as you're alluding to, it's not just donate your voice and listen to others. There's another side of Common Voice, which is you need to be able to read sentences. And so part of our effort for launching in new languages is collecting sentences in these new languages for people to read. And because the data that we are publishing at the end of the day is public domain, CC0, these sentences have to come from the public domain. And so it's pretty hard to find these sentences, because most material that you find that's written is copyrighted. For instance, news sites, podcast transcripts, movies, books, usually copyrighted. And so what we've been trying to do is crowdsource the collection of these sentences as well. And most recently, how we did this is Mozilla has this thing called the Global Sprint. And it's a 2-day hackathon where people all over the world get together and try to contribute to open source projects. And so we participated in this, and we had contributors from all over the world try to collect sentences in their native languages for people to read on Common Voice. And part of that was them writing their own sentences, or taking their blog posts, or maybe text messages. But then they're also kind of scraping the internet, trying to find places where there were public domain materials and collecting them. And over this 2-day period, we were able to collect about 30,000 sentences in 30 languages, which is a good start. But I think we will need to do more of this sentence collection. So this will be a way to participate. Right now, our process is pretty kind of messy de facto. It's not on the website itself. It's on a whole nother website and tool. But we want to get a nice story around that. And so if that's something you're interested in kind of spreading the word about, like, talk to me about that. We'll find ways to, we'll find entry points for you to talk about and how we can get involved in that. So that's another piece, sentence collection. And then the third piece, which I think you mentioned, was technical. So the website itself is what I'm about to talk about in a minute here, but it's an open source project on GitHub. And it's a React app with a Node.js backend and MySQL database using S3. We'll talk about all of that, but absolutely we want people to come and contribute to this, and we have some help wanted bugs. And so far, actually, it's been a really successful project in terms of getting contributors. We have 170 people who have already contributed to that project. So it's been pretty successful in the community. And if you're a web developer, there's a great story around contributing to that, which I can talk about in just a minute. Yeah, are there any other questions?
Yeah, just one question. What's the name of the repository exactly on GitHub? Because there is multiple ones.
Yes, it's the top one. So it's github.com/mozilla/voice-web.
Okay.
Yeah, that's the one.
Perfect.
Yeah, maybe we can put a link somewhere.
Yeah, I'm gonna put the link in the Etherpad. And yeah, and you can. I don't have more questions, so you can move on to the next slide.
Okay, let's see. I have to just switch my slides here.
Yeah.
Let's see if I can do this without crashing my computer. All right, let me go back to the beginning. Okay, so sorry for the disclaimer, but these are not my slides. I do know about the technological side, but I'm not the primary developer here. And our primary developer, as I said, he's kind of heads down, finishing up the last pieces of our launch. And so unfortunately, he just couldn't make it today. I'm going to try to go over this. As I said, if there are questions, I'm happy to follow up with you afterwards and happy to connect you to Gregor, who is an excellent developer and also an excellent person in general. And he's really great to talk to. So I'm sad he can't make it, but we'll move on nonetheless. The show must go on. So this is the architecture of Common Voice, which is a responsive web app. We have the website that you've seen a little bit already. It works in Chrome, Firefox. It does not work in Safari. It works in mobile Chrome and mobile Firefox. And then for iOS, we have a native app. But our native app is really just a wrapper of the web page itself, and then it kind of polyfills some of the APIs that we need, specifically how we access, how we do transcoding of audio data. But I'm not going to get into that level of detail. For now, we just have an iOS app, a responsive web app. Okay? Great. So what we're going to talk about today, we'll give you a kind of intro of what the code looks like, some high-level questions, and then we will go over kind of some of the architectural type stuff. And we'll be happy to answer any questions that you might have about that and about contributing. Okay, and part of what Gregor was going to talk about today was what he did when he came in and took over this project. Because originally I built this a very quick prototype, and then when we realized that people actually wanted this, we brought Gregor on to really come in and industrialize the website. And so, he did some really cool stuff, like he moved to the latest technologies. We were using Gulp before, now we're using Webpack. I was using Preact because I love the lightweightness. He loves React 17 and all the fancy new features of that, so he migrated to that. He also started to use Redux to kind of handle some of our local caching of data. And then server-side syncing. And then towards the end of this, I want to talk about our dependency tree and like what kind of modules we have, and then some of the kind of future direction of the site. Yeah, so if you don't know about what Gulp and Webpack are, these are build tools. Gulp is kind of a imperative, meaning like it's almost like a programming, it's almost like running a script. Like you tell it what to do step by step. And you have some tools for doing this stuff. You have some great, like a streaming API for transforming data. But it's pretty simple to understand because you're basically running a node file. Webpack is a little bit like a bundle of magic. You kind of declare up front, you say, hey, Webpack, I want my site to work like this. And then you talk about like how it does the dependencies and also how you basically set up front, you configure it, and then it figures out how to do everything for you, which there's tons of functionality built into that. For instance, you could do server-side rendering if you wanted to. There's tons of like magic transcoding like Babel in the pipeline. There's tons of stuff you can put in the pipeline. So we wanted to move to this because this is quickly becoming kind of the paradigm for build systems in the web. Like it or not, I tend to love the imperative style, but it's also kind of can become messy. And so Webpack kind of hides all of that complexity for you. And so you get some nice kind of out-of-the-box features if you embrace embrace the ecosystem, which we are doing now. And then Preact to React. So the reason, so if you haven't heard of React before, so I'll just say what that is. That's a front-end, it's a front-end framework for when rendering your web app. And then Preact is actually a version of React, which is much, much smaller. And one of the reasons I stayed away from React for so long is because I used to work at Firefox OS. And if you were to try to bundle, for instance, 100 kilobytes of JavaScript just to even get started building your app, this would already cause some of these slower devices that I talked about, like a $20 smartphone. It would probably take 10 seconds just to parse that much JavaScript. And so my internal Firefox OS developer tends to stay away from these frameworks because of heavy load. Now, of course, that's no longer quite as true. Smartphones are much more powerful than they used to be. React is actually not as heavy as it used to be. But in any case, I started with Preact because of the lower footprint. But React has a lot more features that we wanted to do, and especially it just integrates very well, as I mentioned earlier, embracing the ecosystem, allowing us to kind of use what are the standard tools, allowed us to really benefit from kind of embracing this ecosystem. Forgot to mention, we are also using TypeScript as, so it's not just a vanilla JavaScript application. We use TypeScript both on the front end and the back end. Yeah, and then of course we started to use Redux. So in the early days of Common Voice, everything we were very much privacy centric. So all of your profile information was actually stored just in your browser. We didn't store it in a database anywhere. We wanted to keep it kind of out of our hands, and a lot of this had to do with us being afraid to have personally identifying information inside of voice data, and I'll talk a little bit about that later. So we were just using things like local storage, right? And so I think this moving to Redux allowed us to kind of have a more standardized way of keeping our data locally, but then also we added a server-side database as we started to embrace identity on the website, and we're soon going to be adding logins, and so Redux allows us to do a lot of keeping things in sync a lot easier and doing things in a more standardized way, as I said, embracing the ecosystem, which I think all of these changes really did improve the usability of our product and allowed more people to contribute because they're more used to these technologies. Because in the early days, I just wrote everything from scratch. Okay, so on the front end, these are kind of the components that we have. You can just kind of get to see what the size of these different pieces are. So, it turns out that React and React DOM are big, but not like so hugely big that it dominates everything inside of our application. So it made sense to make the switch. Going forward, we are tentatively planning to start using CSS in JavaScript. And what this means is abandoning style sheets, or in a way, at least abandoning style sheets, so that all of our CSS gets injected, gets defined and injected straight into our React components. This is a very controversial thing, and I'm not here to defend this decision. What I will say is that this allows us to support right to left languages way, way easier. And so this is kind of a best practice for right to left. And so regardless of whether you like this practice or not, a lot of me rejects this because I spent 10 years of trying to encapsulate CSS and JavaScript separately and have these things apart, and now all of a sudden they're being mixed back together. But there's actually some really great features that this provides, and so we're probably going to be moving to this. We haven't done it yet, but especially if we want to support some right to left languages, I think we're going to have to. Okay, so this is the basic architecture of our backend. So this is not the front end side, but the backend. The backend is a Node.js application. It's also using TypeScript, and it also uses Webpack to do the building. At the very front of the backend, we have our API layer, and our API layer has both has like a couple of different things that I want to separate out for you here. We have our way of tracking the clips or the audio files, and then we have our database or our model. The reason why these are separate is because when we publish this data, the voice clips itself, we don't want to have any personally identifying information. So no matter what kind of user you are, no matter what kind of identity you have, what kind of profile you have on our site, which could include things like your email address or your amount of contributions, your social connections, et cetera, we want to keep that completely separate from the voice data. The voice data is all completely anonymous in a giant bucket. And so we've built our application to keep these things very separate. Of course, there can be communication between the two, but architecturally speaking, they're always separate so that we can ensure our users' privacy. So that's what I kind of wanted to call out here. This is, if we actually drill into how these components look, it's a little bit more complex, but the overall paradigm that I just showed to you is what we have achieved through this encapsulation. And this is the diagram of kind of like a user flow. Again, this is just to illustrate that this is the thing that I had to draw for our legal department to ensure them that our voice data is completely separate from our internal database. We want to make sure that our users' privacy is protected and that their identity is protected in this data. And so we go through great pains to keep those separate. And so this data flow is something that we have to adhere to even as we go forward. Yeah, one of the things you may be interested in is we have a MySQL database now and how we do migrations. I don't know how familiar all of you are with infrastructure we have here at Mozilla, but we have an operations team that has an open source project called Nubis, and this handles all of our cloud deployments. And so what Nubis does is it allows us to have clusters of machines that represent a deployment. And so the way it works is every time we push code to master, so every time we merge a pull request, for instance, we have a staging machine who is pulling this data in and rebuilding a cluster of machines. And what's cool about Nubis is that it makes sure that it will always have uptime. So it has its running existing cluster. It will build a new cluster, but keep the old cluster around until it's sure that whatever changes you've made build and pass all of its tests. And once it's done, it says, okay, throws out the old cluster, brings in the new cluster. And we also have a staging and production version of this. And so this is great, except for when we want to do schema migrations, because we have clusters of like 3 to 10 machines, depending on load. And so how do we know like which machine is going to do the database migration? And when I say migration, I mean like changing the schema of the tables, adding tables, dropping tables, adding columns, stuff like this. We need to make sure only one machine does this. So we have a process for what's called election or leadership election. So these machines, they communicate with each other and say, okay, you're it. And then this machine will basically take itself offline, run this update to our database, and then Once everything is done, it just goes back into the cluster. And so that's kind of what this schema migration thing is about. This is mostly owned by Gregor now. So if you have actual questions about this, I can't tell you a whole lot detail, but I could certainly put you in touch with him. But that's it, actually. So that's kind of the rundown of the application. We have, as I said, the project's on GitHub, and there's a link to it now on the Etherpad. We have help wanted bugs, but a lot of, to be honest, right now, a lot of the ones that are left are kind of the trickier ones. We need to start adding some new help wanted bugs, which we will be doing soon, probably right after launch. So this week, you'll see a bunch of more help wanted bugs coming up. And as I said, just a Node, React, MySQL, and S3 backend. That's it.
Perfect. So volunteer can contribute in the backend?
They absolutely can, to both the front end and the back end. We have a contributor's guide on the GitHub page itself that kind of can get you up and started. If you're a fan of Docker, we have a Docker container you can use, but you can also just install the technologies yourself or create your own virtual machines. It should have everything there to get you started with a local development. If you find any bugs in that, or if you have problems with that, let us know, because we need to fix the documentation.
That's perfect. Javi, do you have anything? Do you have any question? Do you see any question somewhere?
Let me do one more check. I have not seen new questions coming in. This is so excellent. Thank you so much, Michael. You gave Gregor's deck with authority. You could have gotten away with not telling us it was, and just so you know the impression that that was super helpful. I was actually looking for the specific link from the repo to the contributors guide, and I'm going to drop that in the Etherpad. But I
did that.
Oh, you did that already?
Yeah, I already have done it.
Oh, very good. Okay, cool. Then last call in the channels, if you're on Telegram and you have a burning question for Michael or his colleague Gregor, you can drop it here now, you can drop it here later, and we will route it over to Michael. And I think that might be it for today. So good luck with your rollout, which sounds like it's happening real soon, and look forward to whatever's next. And I hope you'll come back in, I don't know, a couple of quarters or something like that, and share an update. So
I would love to come back. Thanks so much for having us. Thank you, tech speakers, for your interest. Please keep in touch with us. I'd love to speak with you at any time. Like, our door is always open, and I think this program is really cool. So
okay,
yeah.
Just one, and thank you again. One extra thought. If people want to join the Slack channel or the discourse, have we put in those links together in the Etherpad, or maybe we can look those up, and if there's anything else they need to do. So is that right? There's a public Slack and a public discourse. Yeah. So we'll gather up those links and share them in the Etherpad as well.
Yeah, that's great. Good
safe
call
travels.
out.
Yeah.
Thank you.
Yeah. Thank you, Javi. Thank you, everyone.
For hosting. Yeah.
Yeah, thank you, everyone. Looks like this is the end of our tech briefing. Thank you, Michael, for this very, very informative presentation in the both way, the technical way and contribution way. And now I feel like I have more idea about Common Voice in the technical way also. Yeah, thank you a lot. Thanks everyone. And we will, if you have any more questions in the Etherpad, we will try to forward them to Michael. And you can find his information and contact in the Etherpad also, so you can feel free to send him an email or anything, or to get in touch with him anywhere. Thank you. Thank you, Javi.
And thank you, Khan and AV Ops, for your support.
Yes.
All right.
Thank you, Khan.
Okay. Ciao.